Hello friends, very good morning. Myself, Professor M.H. Annaya, and in today's video, we are going to study the development of the lateral surface of a hexagonal pyramid having base side measuring 30 mm and height is equal to 60 millimeter. And it is placed on HP with an edge of the base parallel to VP. So friends, initially we place the object on HP such that one of the base edge or two base edges of the base are parallel to VP. So let us write down the top and front views of the pyramid when it is resting on HP on its base with one of the base edge parallel to VP. Hence, in the top view, we are going to get a regular hexagon of side 30 mm with the center or the vertex joined to all the corners of the base. So let us commence the problem by drawing the top and front views of the pyramid. Friends, top view is going to be hexagon, I told you. And this is a hexagon, and I am going to join all these corners. Friends, this is how the pyramid looks in the top view, and each of these sides measure 30 mm. O is the vertex, the center of this, and we will name this as A, B, C, D. A, this is B, corner C, D, E, and F. Friends, let us obtain the corresponding front view for this. So in the front view, friends, you are going to see 1, 2, 3 triangles you are going to see in the front view. How to obtain that? Friends, from these corners A, B, C, D, etc., you draw vertical lines to touch XY or to meet XY at these points. So on this B and F line, on this you will get C and E, and if you just mark all these on XY, this will represent the base of the solid. So marking will be like this. This is A dash, this is B dash, F dash, this is C dash, E dash, and the last point is D dash. We have O. From O, draw a vertical line to represent the axis and that mark a height of 60 millimeter, the height of the solid or the height of the pyramid. This is 60 mm. And here, friends, this point represents O dash, the vertex of the pyramid. Now let's join this vertex to all the corners. So O dash to A dash, O dash to D dash, O dash to C dash, O dash to B dash, and this is C and E. Friends, this is how the pyramid looks in the front view. That is, this is the base and this is the height, and the axis of the pyramid is perpendicular to HP. We will call the center of the base as O1. This is O comma O1. This is dash to represent the front view. Now we have completed the first part of the question, that is obtaining the top and front views of the pyramid when it is resting on HP on its base with one of the sides parallel to VP. I can say this BC is parallel to VP, or you can say here this EF parallel to BC, parallel to VP. So obviously this is also parallel to that. And now in the top view, all these base edges, namely AB, BC, CD, DE, etc., represent the true size of the base of the pyramid. And to draw the development, we need to have the true length of the slant edges connecting the vertex to all the corners of the base. And friends, here the top view of this slant edge O dash D dash is OD. Since OD is parallel to VP, O dash D dash represents the true length of all the slant edges. This is the TL. TL means true length. Now friends, using this true length, let us draw the development of the pyramid, assuming it is not cut by any section plane. So friends, here I am going to mark a line of length is equal to true length. Mark this as O, the vertex. Now taking O as center, the true length as radius, I am going to draw an arc. So this arc is drawn using vertex O as center, true length as radius. I have drawn an arc here. On this arc, friends, I am going to step off all these 6 edges of the base. So 6 times 30. So I am going to mark 30, 30, 30, 30. 1, 2, 3, 4, 5. Once again, I want to have one more. So I will show it here. So friends, I have marked all these base edges, join that to this. So this is also true length, and I am going to join all these points on the arc to the vertex O. So this is 1, 2, 3, 4, 5, 6, because there are 6 slant edges and the slant triangle. That is the inclined triangles to the base. There are 6 in number, and these are the 6 edges I have shown. The edges are always straight. So I am going to mark this by straight line, straight line, straight line, and straight line. So all these measure 30 millimeter each. So let me show at 2, 3 places, 30, 30, 30, etc. Now let's move on to the section plane. A section plane which is normal to VP. Friends, any section plane which is normal to VP is seen as a line in the front view, and where that section plane passes through, it is inclined at an angle of 30 degrees to HP. That line is at an angle of 50 degrees to HP and is passing through a corner of the base. Friends, here the object is resting like this. This is how it is resting. The section plane is to cut this solid at an angle, and it has to pass through one of the corners. It could be this corner on the right or the corner on the left. So let us consider the leftmost corner, that is A dash in the front view. So friends, I am going to draw a line passing through this point A, inclined at 50 degrees to HP. So I'll just mark that line. So this is the section plane SS, which is at an angle of 50 degrees to HP. 50 degrees to HP. And it is passing through one of the corners, that is A of the base. And now friends, after the section plane cuts this pyramid, we have to retain one part of that, because it's cut into 2 pieces. We have to draw the development of this surface. It says in the question, draw the development of the lateral surface of the lower parts of pyramid. So lower part means what? So from here till here, this part is going to be retained now, for which we are required to draw the development. So we'll have one edge here, an edge here, and this is how the section plane looks. This section plane is cutting the pyramid at an angle of 50 degrees to the horizontal. Now friends, comes next is the location and marking of these slant edges. Friends, if you observe this, we are going to retain this part P for drawing the development, and hence this part is thrown out, the upper part above the section plane. And now here if you observe the front view, friends, this slanted O dash A dash is totally removed from this section, from the solid. That is to say, this OA is totally removed. And when we draw the development, we should take care to see that we commence the development only from that slant edge or edges that are removed. Here we have only one choice of drawing this development commencing from A because OA is removed. So this is B, point C, D. This is E, F, and again A. The starting and the end point should have the same marking. Friends, after getting this development, we shows the development of the hexagonal pyramid without the section plane cutting it. Now, let us see where all the section plane SS is cutting the solid. Let us start from this end. Friend, the section plane SS is passing through A dash, the corner of the base. So, I will mark that point here. This is a point on the base is passing through A. Then friends, this line or this OB and OF are cut here. So this is not the true length. Hence, I should shift this to the last line, which is the true length line, and mark that distance on OB and OF. OB I mark and OF. Same distance I should mark. So I mark these 2 points. This is over, this is over. For the axis you don't mark anything. And here the section plane is cutting OC and OE. Again OC and OE are not true length. We have to shift that point to the last slant edge, that is end slant edge, and mark this on OC and OE. OC and OE. This is OE and this point is OC. Same measurement we are taking. And friends, the section plane finally is cutting this last slant edge OD at this. OD is the true length. Hence, I take this measurement directly and mark on OD. OD is here. So friends, we have got 1, 2, 3, 4, 5, 6 points. We will join all these points by straight lines. So I will join A to this, then this point here, this point, this, then this point, finally to A. And if you want, friends, you can mark this numbering also can be done. This is 1, 2, 3, 4, 5, 6, and again 1 here because A is common. So 1 on A, so this point is 1. You can see here. 2 on OB. OB is here, you got point 2. And also on OF, it is 6. 2 comma 6 is this point. Then here you have got on OCOE, this is 3 and 5. 3 comma 5 is this point. 3 comma 5. Finally on this you have got point number 4. So this is how the solid is cutting. And if you observe the figure, friends, the complete base of the solid is intact. So I have to show all these base edges, namely AB, BC, CD, DE, EF and AF by dark lines. And friends, the portion between the section plane and the base is intact. That is, on OD you should have this length, and on OC and OE you should have this length. So these portions are also retained to be shown by dark line or visible line. So friends, this portion 1, 2, 3, 4, 5, 6, 7 with this base will represent the development of P, the lateral surface of the lower part of the pyramid. Friends, I hope the presentation was interesting, and if you like this presentation, please share the information about this video to all your friends and have a blessed day. Thank you very much.